In this video, we are going to be learning about aldol and cross-aldol condensation. Before we understand what aldol and cross-aldol condensation is, we need to know what an alpha hydrogen is. Let's take two examples, an aldehyde and a ketone. So we are taking propanaldehyde or propanal. So it has to have 3 carbon atoms. This is propanaldehyde or propanal, and we're taking propanone, which is a ketone. Okay, now propanaldehyde and propanone, both of these have a carbonyl group. So the functional group is going to be this part. So this is the functional group. So the carbon which is attached to the carbonyl carbon is referred to as an alpha carbon. So all these three, this one is directly attached to this carbon, this and this carbon is attached to the central carbon. So all these 3 carbon atoms are alpha carbons. The hydrogen atoms which are attached to the alpha carbon atoms are alpha hydrogen atoms. So the ones which I've circled are all alpha hydrogens. So in case of aldehyde, this is not an alpha hydrogen. No, it's the one which is attached to the alpha carbon atom that is considered the alpha hydrogen. And aldol and cross-aldol condensation involves the alpha hydrogen. So in case of aldol, so we'll start with aldol first. So aldol condensation involves a self-condensation reaction. So it is self-condensation, which means there are no other molecules, there's no other aldehyde, there's no other ketone. It's the self-condensation of that particular compound. So instead of telling you about each reaction step, let's look at one of the reactions and then we'll go from there. So we are taking the example of ethanol. So it does have an alpha hydrogen. It actually has 3 alpha hydrogens because CH3. So this is going to undergo self condensation in the presence of a dilute alkali, and this dilute alkali is going to be NaOH. Okay, now this leads to the formation of something called an aldol. Okay, so basically you'll have an OH group, a hydroxy group. So this is going to get converted to an OH. Okay, and this is going, this, because this is getting attached to this carbon atom. So here you have hydrogen and a hydrogen and COH. So this particular substance or compound consists of both an aldehyde as well as an alcohol, and that is why it is called as an aldol. Okay, so basically here if you notice, this hydrogen stays, it's here, down here. So this hydrogen is basically moving from this carbon atom to this, to the oxygen, double bond breaks, and so a new bond is formed between the 2 carbon atoms. Now this compound is quite unstable and loses, oh actually I'll do one thing, I'll write it beside. So okay, anyways, so this is losing a water molecule. So it's losing a water molecule, and this leads to the formation of an alpha beta unsaturated carbonyl compound. So here what happens is there's going to be a double bond between these 2 carbon atoms because this and this is going to be lost. So this is an alpha beta unsaturated carbonyl compound. The reason this is called alpha beta is because this is an alpha carbon, this is the beta carbon to the carbonyl group. So Aldol condensation involves the self-condensation of an aldehyde or a ketone that consists of at least one alpha hydrogen atom, and this leads to the formation of an aldol in case of an aldehyde and a ketol in case of a ketone. So let's write it. Aldehyde is going to undergo self-condensation in the presence of a dilute alkali, okay, to give us an aldol. And this is going to lose water to give us an alpha beta unsaturated carbonyl compound. So alpha beta unsaturated carbonyl compound. Okay, so aldehyde is undergoing self-condensation in the presence of dilute alkali to give us an aldol. Aldol is unstable, so it loses a water molecule and gives us an alpha beta unsaturated carbonyl compound. And the reason we call it aldol is because it consists of an aldehyde group and an alcoholic group in the same compound. So in case of a ketone, the same thing happens, but we get a ketol. Okay, and here also it loses water to give us an alpha beta unsaturated carbonyl compound. Okay, so let's do a ketone as well, and that's butane 2-enal. I'll just write the name of this compound. I forgot to do that. Butane 2-enal, and we don't mention the number because the aldehyde gets more priority than the alkene. If you don't remember that, do check out the nomenclature or recap on the nomenclature. You need to know the basics of nomenclature at least at this point. So here we are going to take a ketone. So we are taking propanone. So CH3CO CH3 is going to react with another molecule. So CH2CO CH3. So basically this hydrogen atom is going to come get attached to this. Okay, if you want, you can pause the video right now and try solving or try doing this reaction on your own. See if you're right. If you're right, yay, you are able to do it. If you're not, you're learning something new right now. So it's going to be similar to what happens here. Instead of an aldol, we'll be getting a ketol. So if you've paused and if you tried, good job. So NaOH, and here, so here, like the last time, we had to simply put this, in the last time we had a hydrogen here, but at this time when we are having a ketone, we are going to have a CH3 group here, and in this place also we are going to have a CH3 only. So CH3, this one, C single bond OH because oxygen came and attacked, then a CH3 and CH2 because this carbon loses a hydrogen, that's why you get an OH over here, and CO CH3. Last time you had a H. In this case, you are going to have a CH3, and a ketol is obviously not going to be stable, so it will undergo loss of or dehydration or loss of water because it has to lose this one, and we get minus H2O. Okay, so we get CH3, an alpha beta unsaturated carbonyl compound. That's about it. So aldehydes and ketones undergo self-condensation in the presence of a dilute alkali to give us an aldol and ketol respectively. Aldol and ketol are quite unstable, so they lose a water molecule to give us an alpha beta unsaturated carbonyl compound, and all of this is possible only if that particular compound has an alpha hydrogen. So with that, we're done with, oh, I forgot to write the name. The name of this is 4-hydroxy. Oh, I'm sorry. The ketol's name, 4-hydroxy, 4-methyl, pentane, 2-one, and this compound's name is 3-hydroxy butanal. And this compound's name, the product that we had gotten, is 4-methyl pent 3 ene 2-one. So that's about aldol condensation. So by the way, the name aldol is applicable for ketones as well. It's just that they didn't want to come up with a new one for ketones separately because it basically follows the same steps. One more thing, if a particular aldehyde, like let's take benzaldehyde. Okay, now in benzaldehyde, the alpha carbon is going to be this one. This is the alpha carbon, right? This carbon. This carbon will not possess another hydrogen. So this carbon does not have an alpha hydrogen. So this won't undergo aldol condensation. So what I'm going to do is, we're going on to cross aldol condensation. So let's just erase this bit here. So cross aldol condensation is going to be between two different aldehydes or ketones. So this will lead to the formation of 4 products. So let's look at it. Let's take an example. So if both of these both the reactants consist of an alpha hydrogen, we will get 4 products. So let's take the example of CH3CHO. That is, this is ethanol, is reacting with CH3CH2CHO, which is propanol. So there are 4 products which are formed, and we are only we are directly talking about the end products. We're not talking about the aldol or ketol. We're talking about the alpha beta unsaturated carbonyl compounds. So in the presence of NaOH, so we're doing both the steps in one go. And the second step is going to be from heating. Okay, loss of water. So first we'll talk about the self-condensation products. So first they will undergo self-condensation. So if they undergo self-condensation, the number of carbon atoms is going to be 4. So CH3, okay, C double bond, C single bond, COH. Okay, and so this is but2-ene-al. So the second product which will be formed is with the propanaldehyde, right? So propanaldehyde, this is the alpha carbon atom. Okay, so the first compound CH3CH2 C double bond. So okay, so to make things easy, let's write it like this: CH2 CHO. Okay, this will be the first aldehyde compound. The second one is going to be CH2 CH3 CHO. So this is going to react with this. These two are going to react. So here this carbon atom is actually going to have a CH3 group attached to it, because it will lose the hydrogen atom first to the aldehyde, and the second hydrogen is going to get lost because of the formation of or removal of water. Okay, so here you will have a double bond, and then you have a CHO. So these are going to be the self-condensation products, and this is called as 2-methyl pent 2 enol. So that these two are the self condensation products. Next we will have the cross aldol products. So there are two ways. One is this is going to react, this is going to be on the left and this is on the right, or this could be the aldehyde of this compound could become or could be lost and this will stay. So that's how we have two products. So let's start with taking these as it is. So we'll be having CH3CHO plus CH2CHO and CH3. So this is the first one. Okay, so basically there will be a bond formed between the aldehyde carbon and the alpha carbon. So CH3, C double bond carbon and methyl group plus, CHO. This would be the first compound which is formed, and this is called as 2-methyl but2 enol. So the second compound that could be formed is because of CH3CH2CHO plus CH3CHO. So this carbon's hydrogen, this alpha hydrogen is going to come attack the aldehyde. So the aldehyde group is going to get lost and instead we'll be having an alkene. So CH3, CH2, CH double bond to this carbon, CHCHO. Okay, and this compound is called as pent2 enol. So that is about cross aldol condensation. We have another reaction, but with respect to this reaction, when we have two different aldehydes, both consisting of an alpha hydrogen, then we get 4 products. 2 is because of self aldol condensation and 2 are because of the cross condensation. So when we were talking about self, it's quite easy, it's similar to this one. Okay, do one thing. If you find this very difficult, put down the name of the compounds like how I did over here, the structures of those compounds side by side. Okay, the one which is on the left, take it into consideration that the one which you're writing on the left is going to lose the aldehyde group and it's going to have a double bond, and the one on the right is going to retain the aldehyde group but it is going to lose the alpha hydrogen. And the moment you put it down like that, for example in this case it was CH3 CHO plus CH2 CHO and CH3. This was for this one. Okay, so the one on the left is going to lose the aldehyde group and we're going to form a double bond here. That double bond is going to get replaced by a double bond with the alpha carbon. And in this case it was CH3 CH2 CHO plus CH3 CHO. So the one on the left is losing the aldehyde group. Isn't that what happened over here? And this one is losing alpha hydrogen atoms to form a double bond. So if you write it like that, it will be easier for you to figure out how they are different from each other and how the products are going to be formed. For you to do all of this, you have to be clear as to what is happening in aldol condensation. So if you can write these products, it's obviously going to become very easy for you to write these ones as well. So if one of the compounds, in case of cross aldol, if one of the reactants, they do not possess an alpha hydrogen, they will not undergo self condensation. So let's take the example of benzaldehyde, and we are going to be taking the example of a compound's name whose name which you will be commenting in the comment sections. So this compound, it's obvious it does not have an alpha hydrogen. So it does not undergo self-condensation. Instead it will undergo reaction with this one, and this is the alpha hydrogen. I'll do one thing. I will flip these two. One second. Oh, I was right. One second. So CHO, CH3. Okay, so here you have an aldehyde and a ketone, but this aldehyde does not have any, and this is a CH3, if that was not clear. Oh god. Yeah. So this will undergo condensation, and pause for a second and think what the product must be. So this is going to be heated at 293 Kelvin. It's going to be at 293 Kelvin. So here, this is going to lose the aldehyde group because it does not have any alpha hydrogen. And this compound is going to lose its alpha hydrogen atoms. But the ketone group is going to stay. So, pause over here if you'd like to try writing the product on your own. So you are going to have a double bond, CH. So it's going to lose 2 of its hydrogen atoms to form the double bond, and CO. This is the product formed. So yeah, aldol and cross aldol condensation. Aldol is basically self-condensation in the presence of a dilute alkali to form aldol, which undergoes dehydration to form a alpha beta unsaturated carbonyl compound. One more time, I'll just do this. So in this case, we are taking two compounds, the same aldehyde, two molecules of the same aldehyde, that is ethanal. So in this ethanal, the first molecule is losing the aldehyde group and it is getting converted. This O is going to get converted to an OH, and then that is also going to get lost. So leave this part for now. So if you notice these two and that one, this compound, this carbon atom has lost the oxygen and has formed a double bond with the alpha carbon atom of the second one. So second molecule. And this has lost the 2 hydrogens. So always remember to, for it to be easier for you to write these products, have the one which is losing the aldehyde group on your left, on the left, and the one which is losing the alpha hydrogen on the right. The moment you do that, it will be easier for you to write the products. So in case of aldol, it's basically self-condensation, whereas cross-aldol condensation involves 2 different molecules which have an alpha hydrogen. If there are 2 different molecules and both of them have an alpha hydrogen, then we get 4 products, 2 by self-condensation and 2 by cross-condensation. And here I've written down the way these 2 compounds have formed, and if one of the molecules does not possess an alpha hydrogen, then it will not undergo cross aldol. So when it reacts with another molecule that possesses an alpha hydrogen, it will form only one compound, because the other way around, that particular compound cannot form, and this compound cannot itself undergo self-condensation. With that, we're done with aldol and cross aldol condensation. In the next video, we are going to be talking about Cannizzaro reaction.